All right, I have the sign that it works, so we can start. Good afternoon, everyone. My name is Tomasz Manugiewicz, and today I would like to talk to you about autonomy and how we can gain autonomy and ultimately how it can improve our software design. So I have a question at the beginning for you. Do you feel autonomous at work? Who feels that he or she is autonomous? Raise a hand. Okay, many people feel autonomous at work. I like it. So I don't need to deliver this talk to you, right? Because you are already autonomous. But what I observed in my company and the other companies I was working for is that people, tech people usually complains about autonomy. So that we are not autonomous, we are dependent, there are cross dependency in the teams and so on. Why is so important for us to be autonomous? Because we want to be in charge of our lives. Basically, we can make decisions on our own. And this is a self-determination theory that I would like to mention to you today from Mr. Ryan and Deci. And they said that those three aspects are the most important in terms of our intrinsic motivation. So the competence, relatedness, and autonomy. Competence because it gives us the influence on the world around us. Relationships or relatedness because we are human beings and we all relations. And the third, autonomy, because you would like to be self-governing. So on this autonomy part, I would like to focus today. What I observed in tech companies is that, as I mentioned, people sometimes complaining about autonomy in the tech industry, but I found out with the developers that autonomy is not only about tech. There is 4 dimensions of autonomy. There is a time, task, people, and technology dimension of autonomy. When it comes to the time, we can be autonomous in deciding when we will be implementing such feature. In this sprint, next sprint, we can juggle the backlog. That means we are autonomous in terms of time. When it comes to the tasks, we are able or not able sometimes to pick up the tasks that we want. So that's the autonomy in terms of tasks. Autonomy in terms of people, and gives us the decision with whom I would like to, for example, pair program or do the code review or produce a feature. And technology at the end, this is the 4th one, how I will do it, which kind of tool I will use it, which kind of technology and so on. So bear in mind, I would like to make sure that we will remember that those are 4 dimensions. And to be happy and fulfilled at work, we need to set our own expectations, right? So we need to remember about those four aspects. Here are some numbers that I would like to give it to you. This is the research done at the Birmingham University, and they found out that actually IT automation industry is the most autonomous industry. I mean, people work in this industries are the most autonomous. So it's not that bad actually in our world. Although those are the numbers from the same research saying that the smaller company is, the higher autonomy in this company is. So on the left-hand side, you have big corporation, 5,000 to 10,000 people almost, and the autonomy is fairly low. On the right-hand side, you have small company up to 100 people, and the autonomy is high. Why is that? So what's the reason? I was trying to digest. As I'm an engineer, I wanted to dig deeper and check what's the reason. And I found this sequence. Do you know what that is? Any of you heard about this sequence? Yes, no, maybe I've heard something. So this is social Fibonacci sequence. This is the unofficial name, and the official name is Dunbar sequence or Dunbar's number. So what this guy did, he found out that we are able to maintain effective relationships up to 150 people. And what does it mean? What does it mean for us? For us, it means that if we have our team, for example, 5 people, we invest a lot of time, we invest a lot of effort in building the relationship. So we have the closest relationship that we can have. And then there is a bigger family or bigger couple of teams in the corporation environment that we spend the time with, but we don't have so much time and energy to build the relationships. So it's closer family, but not so close. And then we have this 50 and 150 number. 150 is the size of the department in our organization, which means that we are connected with some of the people. We know each other in this department, but we don't have the time to maintain the relationship. So if we don't have time to maintain relationship, we don't have trust, or we are not establishing trust between us. So effectively 150 is the total maximum number that we are able to maintain. Okay, but what about autonomy now, right? Autonomy is going down when the size of the team is going up, right? So the social Fibonacci is on the y-axis, and on the x-axis is communication. So autonomy is obviously going down. And why? Because we don't have, as I mentioned, we don't have time to build trust between each other. So people don't trust us, so they are not willing to give us autonomy. They would like to control situation, right? So that's the thing. Here are the numbers from the Microsoft. Microsoft get a survey, and 87% of employees responded that they feel they are productive at work. And at the same time, 12% of the leaders just mentioned that they believe that people are productive or teams are productive. Why is that? This is basically this gap that people don't have, the leaders don't have the time to spend with the team, so they don't know what's going on, and they don't feel that way. Okay, but how it's connected with our software design then? I would like to introduce this person, Mel Conway. Any of you know about Mel? So this is still very active on Twitter scientist, and he was working in the IT industry for many years. And what he said is that organizations are constrained to produce designs which are copies of the communication structures of those organizations, which really means that we produce the design which reflect our relationships in the company. And I will give you the example. For example, when you think about the reasons behind, we have limits in communication. As I mentioned, if the company is bigger, people are not connected to each other. So designing the software can lead us to the situation when, for example, our team will decide, okay, by the book, this feature should be developed by other team. But you know what? We don't have so much connections with them, and we feel that we will do better, right? And at the end of the day, we'll take care of it. And our design is influenced by the relationships in the company. Also, another example is about securing our own interests. So again, the team who designed the software, first things first, what they do, and that's natural for human beings, but what they do, they secure their own interest. If we will be safe, if we will be beneficial from this design. So that's the second thing that can influence our design. Belonging to the tribe, as Spotify a couple of years ago defined the model, and they said that belonging to the tribe is actually really good, and it is, and we all know that. But there is a drawback on the other side, that if we belong to the tribe and feel very connected, we can block the world around us. In the meaning that, again, we will implement something that we want in our team, and maybe we can design, include in the design some components which we don't want to implement because of various reasons, and we'll push it outside of the team. So that's another drawback. And cognitive lead theory, that's a very interesting part actually, because this theory says that our brain process certain amount of information, and if we are making design decisions, we don't want to be in the position that our brain, maybe we won't, but our brain doesn't want to be in the position that he will learn something new while deciding. No, in that case, when when our brain decides, he or she obviously uses the information they already have. So how then to improve our software design? We can use Conway law in the reverse engineering mode. So as you see on the left-hand side, you have small distributed teams. It usually may produce the microservices-oriented architecture, right? When we have large collocated teams, usually we think about bigger system, right? Because we have a huge department, we can think about the bigger system. But we can do reverse engineering, as I said. So let's first design the software and decide microservices and small services or monolithic. And then based on the design, we can reshape the organization, the teams, the structure. That's a very comprehensive task, but it pays off. So basically, first think about the software and then think about how to set up the organization. I would like to recommend this book for you, Team Topologists. This book is really interesting in terms of how to set up the teams. You may have heard about this book because it's a hot topic nowadays. What I would like to get out of this book is just the right-hand side. So on the left-hand side, you have the setup of the teams defined in this book. I will not spoil that, it will not go through it. But on the right-hand side, you have team interaction models. 3 models: collaboration, X as a service, so our software as a service, and facilitating mode. And why it's so important for me? Because the interaction models actually tells how we communicate in the organization and how our organization can be shaped in future. So facilitating mode is all about learning from each other, according to this book. So when we have teams in the facilitating mode, those teams are learning from each other. When we have collaborating mode, this is about working. 2 teams collaborating together, working together, producing software. And X as a service, basically self-service oriented environment. And we do need trust between people in this setup as well, in these modes. Because when we learn from each other, so this first facilitation mode, we need to trust ourselves. First things first, that we'll understand what other person would like to teach us. Second, that we can admit about our lack of knowledge, because this is the only way to learn, right? To admit that at the beginning that I don't know and I would like to learn, so I would like to be open. And collaborating, second mode is about collaborating, so trust each other. When we work together, we need to trust each other, obviously. And software as a service, we need to trust others, that they will use our services in a good way. We will not be able to control them. So trust is everywhere. Also, I would like to show you this DevOps tool ecosystem, because there are a lot of tools, as you can see over there, that you may recognize. What I would like to tell you today is about domains of those tools. So domains of building software, testing software, deploying, running, and so on. can easily lead to the silos. Because if someone is focused on building software, we know that if someone builds software, that's the thing, right? We don't want to work on the operation mode. We want to develop software, right? We don't want to support. Between building and testing, it's already happening that we have QAs embedded in the teams. So this silos is already removed usually, but we have the silos between development and operation, and that's how the DevOps movement started. That development and operations were working, were not connected to each other, were working in the silos, and this DevOps movement told us that we need operations and developers working together. By the way, I saw that Patrick Debois is on this conference as a speaker, and I've learned from the YouTube that he was the one actually initiating the DevOps movement many years ago. So we need to break the silos. All of us would like to break silos, obviously, to have more cross-functional teams. And to break silos, we need to trust, because if people on the building side will be trusting operations, that those guys actually, they know what they do, what they are doing. They will not break our code. They will learn from us. We can work together, and vice versa. Operations guys can trust developers and say, yeah, they are doing a good job. Obviously, some builds are broken in production, but we are willing to learn from developers how to fix that. So this is all about trust. And ideal scenario, living happy ever after, one goal, one mission, and one big family working together. So that's how we can then put this ecosystem to work without any silos. And even DevOps evolution model says in the third stage says about autonomy, so that individuals can do the work without manual approval from outside of the team, which basically means individuals are trusted or trustworthy to do the work without approval from product owner, for example. Do you have any experience on that? Who of you can do the production deployment without any approvals? I like it a lot. Like 1/3 of the room. So, autonomy, it's basically when we are gaining trust, people will give us autonomy, and it's all on all of levels of the organization, with the product owners, with the business stakeholders, with the top management, and so on and so on. So trust is a fuzzy word. It was a fuzzy word for me. As I'm an engineer, I wanted to know what that means, trust. So I thought to myself that we observe the world around us, or more precisely, our brain scans our world around us and take actions, meaning start trusting or start not trusting person. But actually, this is not so easy. So our brain observes the world around us, select the data from reality, in the meaning that about this cognitive load, right? That we are not able to collect all the data from reality. Our brain selects the data, add the context and our experiences, past experiences, make some assumptions. We all are making assumptions, consciously or subconsciously. We draw conclusions based on those assumptions, and then we take actions. So then we decide to trust or not trust. So this is very actually complicated and complex process. And for me, trust is composed of two pillars: the cognitive aspect of trust and emotional aspect of trust. And now, cognitive aspect of trust is transmitted through thinking. So it's easy for us as engineers. It's transmitted through our skills, our knowledge, our experience. So basically, our stakeholders can see our results of our code, and can say, okay, I trust this guy, that this guy will deliver good feature or good product. On the other hand, though, there is a second pillar which is important as well, which is emotional aspect, transmitted through feeling. And we feel, or most precisely our body as well feels, if we can trust the person or not trust. We feel because we see the intention of people. We see that people are open with us and honest with us, so we can trust on this emotional level. We tend to say that the person is in integrity because he or she has this attitude. So those two aspects are important in building trust, because if it's only the results part, but we don't feel that we can trust this person, we will not trust. On the other hand, if it's only a feeling, but we don't see the results, in the corporation environment, again, we will not trust this person that he or she will deliver software to us that we invested the money in. So that's why it's important to remember for you that competence and character, those are the two aspects of building trust. So it is about cognitive intelligence, so all our analysis, logic, language that we use specific language in our IT, right? And all the data that we collect. And the second pillar is about emotional intelligence. And emotional intelligence is to recognize our emotions, understand and manage our emotions and our states. And also to recognize and understand emotions of others. And that's as well difficult part, because when we are in the situation on the tough meeting, for example, during retrospective or planning, or on the project design meeting, there are a lot of emotions usually. And we need to consciously understand ourselves and others where we are in terms of our emotions, and we need to embrace emotions. I know that, as I said, I was an engineer, so for me, trust and emotions like fuzzy words, but it is actually important. And today I would like to introduce Brené Brown to you. Any of you have heard about Brené Brown? Yes, I see some people. Good. I very like Brené in terms of her researches. She does the work about the shame, about trust, about being brave. And she said something like this, that trust is not being built in big sweeping moments, it's built in tiny moments every day. Which basically means this investment of time that Dunbar said. And it can look like this. We have one person from the team joining the team, and we have the senior developer who is in the team already. Both say hey to each other, and subconsciously the brain of the senior developer scans the results and this integrity state in other person every single day, every single moment. And if he or she understands that they can trust each other, the relationship is built. But this is tiny moments every day. Example of this tiny moment is pair programming, for example. Who of you do pair programming? How many of you? Almost all of you. And who of you like pair programming? Oh, like it. That's good. Pair programming, though, is sometimes difficult for developers when I speak with them, because it is a place where we are assessed. I mean, not we, but our code, right? So we can have fear of being assessed when we develop together. For example, let's have an example: junior and senior developer. Obviously, junior developer knowledge is limited. That's why he or she is junior. But he or she this person can have the assumption in their mind that, I'm not good enough, right? I don't know what senior developer will think about my code. I don't know if I will belong to the team because I would like to belong. So this is the place of fear. But vice versa can be the same way, that senior developer can feel fear because he or she supposed to be the senior guy. But what happens if one particular day this code will be not good, right? Or it will turn up that this guy is not so senior based on the code reviews and based on the pair programming exercise. So that's the challenge that we have, fear of rejection. Code review, similar thing, asynchronous process. We are assessing the code, but people may think that it is about assessing the author. I have a good example because I had the developers who were sitting next to each other and they were commenting the pull requests during 1 week. They didn't speak to each other, but they were putting the comments, like 100 comments in the pull request, without any single word and conversation face to face. So that was a mystery and a challenge. It turned out that they had other issues that they had to solve between themselves, but it can be that way. So Brenner says that we need to have vulnerability attitude. We need to be vulnerable. But again, the third fuzzy word, vulnerable, what does it mean? So we know from system world, from IT world, that we even have some vulnerability engineers roles, that vulnerability is a flaw or weakness in the system which could be volatile. So we have those engineers to find those weaknesses and fix them, right? So we are not talking about this, we are talking about human vulnerability. And Brenner says that human vulnerability is the willingness to show emotions or the weaknesses to be seen. And that's connected with code review and pair programming and trust, building a trust, right? Because we can only build trust, we can only be effective in pair programming if we will show our true selves, our weaknesses. We will be not hiding anything because this is counterproductive and we don't learn, but we will show. Brenner also says that vulnerability is the birthplace of innovation, creativity, and change. That's big quotation, but the idea is simple. If we are true selves on the meetings, for example, during the meetings, we are brave enough to share our opinion, to put the ideas, creative ideas. Maybe just stupid questions can be asked, but in general, we are brave enough. But if we are afraid and we don't want to show our true selves, we are, for example, not sharing our ideas, not asking stupid questions. We are afraid of speaking in the group. And there is no innovation if we are afraid, because our great mind can't be seen. It also happens in the metrics environment. Some people says, "Give me your metrics, and I will tell you whatever you want to hear." Right? Any of you have the experiences with the working around metrics? I guess this is a tricky question, so you don't need to answer that. But yes, definitely, we as engineers, we all know that every single metrics we can find workarounds for every single metric. I have examples, like 4 of them from DORA standard. Deployment frequency, right? We all would like to frequently deploy to production, usually every day or a couple of times per day, which is very, very fancy nowadays and productive as well from the product perspective. But what happens if we will have the, for example, competition, and CEO of the company will say, okay, by end of the year, the best team with the most frequent releases will get the bonus. Then we will do the frequent releases, but without any value to the customer, right? We can deploy even one line of code because we are just increasing the deployments, right? And we tend to think that our CEO will be not digging into the Jira ticket, but he will see the metrics, or she will see the metrics, and will give us a bonus. Lead time for changes. The same story. If we measure time, it can be lead time, cycle time, whatever. If we split user stories and features for smaller parts, the time will be shorter, right? And again, it is a good thing to have split on the small stories, right? But we need to be conscious about that, and not doing it just to have small stories, because it doesn't make sense. Mean time to recover, that's the funny one, and that's the true history from my company, that mean time to recover means basically mean time to recover. How much time do I need to when bug on production appears up to fixing? But there are some creativity part as well, because we have the environments which are production environments, just features are hidden. There is a feature flag, and we can say yes or no, visible to the client, not visible to the client. So what the team did, they delivered to production with this flag not visible to the client, and said, okay, we will do one more small fix on production. Meantime to recover, it's there, because they redefined obviously this mean time to recover. The feature was on production, but they were doing fixes. Or we can have pre-production environment, production-like. Obviously, we know that it doesn't work that way, but we can have this production-like environment, and we can say, okay, mean time to recover, it will be up until this, or hidden, not even pre-production, but hidden environment, production environment. Because this is like production, so it will work. No, it will not. Change failure rate. This is the metric that I haven't seen the workaround. So if you have any idea, you can think about it and let me know after the talk. So, landing and finalizing a little bit, how to unlock our autonomy. We need to build trust, as I said, so we need to be open and honest. We need to deliver results, and we need to set expectations to our teams. What does it mean to be autonomous? And then once we are autonomous, we can make conscious decision on our own without approvals, ideally from stakeholders and from top management, about structure of our communication. And even though there will be structure in the organization, we can define the communication layer with whom we would like to communicate and build this relationships, as Dunbar said. Okay, and today I would like to leave you with this quotation from Simon Sinek, that team is not group of people working together. A team is a group of people that trust each other. Thank you very much for this afternoon.